Welcome to section 1.4 and 1.5. Today we're going to have a crash review of inverse trig functions, exponentials, and logs. So let's start with inverse trig functions. If f of a equals b, then which of the following is true? Well, f inverse is the function that goes backwards, so it's going to take b to a. So f inverse of b equals a. And here's a picture over here. I've got f of x equals x cubed. So think of that as y equals x cubed. F of 2 is 8. And so down here I've got the inverse graphed. We see that f inverse of 8 is 2. All right. How do you graph an inverse? Reflect the graph of f around the line y equals x. And you can see in my picture that's what we've done. How do you find the inverse? Interchange x and y and solve for y. So you've got a few homework problems where you have to find the inverse of a function. And then which functions have inverses? Well, there's a picture down here. The inverse function is going to go this way. And so if the function's not one-to-one, so in this example, I've got Edison and Mr. Spaghetti both going to this picture. If the function's not one-to-one, you can't go backwards. So the answer to this one, there are actually two one-to-one functions, and those are functions that pass the horizontal line test. And the horizontal line test is that any horizontal line cuts the graph at most once. So here we see a function that's not one-to-one, and a horizontal line cuts it twice. I've got some videos here that you can watch for basic review of inverse trig functions, and that's also what we're going to do here. I've got the definitions of the 6 inverse trig functions, and you have to memorize these 3. So the important part is this part, the ranges, okay? And here's why. If we look down at this example, find y equals sine inverse of negative root 3 over 2. There are infinitely many angles y whose sine is negative root 3 over 2, but there's only one in this interval up here. So let's change this. Let's take sine of both sides. Sine of y equals negative root 3 over 2, and y is in the interval from negative pi over 2 to pi over 2. So literally what I did is I just used the red box up here. I transformed the statement into sine y equals x, and then I stated the interval that y must be in. Okay, so now it just comes down to knowing your unit circle. If sine of y is negative root 3 over 2, then y is down here, and that's going to be y equals negative pi over 3. Okay, let's do another one. Find y equals tangent inverse of tangent of pi. Okay, so let's simplify the inside first. Y equals tangent inverse. Tangent of pi is 0. So we want tangent inverse of 0. So we take tangent of both sides. Tangent of y is 0. And y has to be an angle. If you look in the red box above, y has to be an angle between negative pi over 2 and pi over 2. Very similar to sine inverse. So the angle that's going to work is 0. Okay, and we'll do one more. Find cosine of sine inverse of negative 2/3. So this one's a little more involved. First of all, let's name the inside. Let's name it y. Y equals sine inverse of negative 2/3. So what we're after eventually is cosine of y. Okay, let's take sine of both sides. Sine of y equals negative 2/3, and y has to be an angle between negative pi over 2 and pi over 2. Now, since the sign is negative, we know that y has to be down here in quadrant 4. Now, sine is opposite over hypotenuse. So the opposite side is negative 2, the hypotenuse is 3, and I can fill in the missing side using Pythagorean theorem. If this is x squared plus 4, because negative 2 squared is 4, is 9, so x squared is 5, so x is plus or minus root 5. Now, since I'm in quadrant 4, x is positive, so this is root 5. All right, and now it's a piece of cake. Cosine of y is root 5 adjacent over hypotenuse, root 5 over 3. Okay, let's move on to the exponentials and logarithms. Logarithms are the inverse of the exponential functions. So mainly we'll be working with e to the x and ln x. And so you should have these graphs burned into your brain. This is y equals e to the x. And if you remember the graph, you get the domain and the range for free. We can see the domain is all x, and the range is y strictly greater than 0. E to the x never crosses the x-axis. Now, if we take that graph and reflect it around the line y equals x, we get the graph of ln x, which is the inverse of e to the x. Now, it's got domains strictly greater than 0, but the range is all y. All right, so let's look at logarithmic functions and properties of logs and equations with logs. Logarithmic equations have two forms, the logarithmic form and the exponential form. So if y is log base a of x, that means that a to the y equals x. The two most frequent logs that occur are log base 10, which we call just log, and log base e, which we denote by ln x. Okay, so for example, let's rewrite these in exponential form and then find the actual value of x. So this first one, this means 4 to the x is 1 over 16, all right? And so 4 squared is 16, but I want 1 over 16, so x is negative 2. Next one, 9 to the x equals 3, all right? Square root of 9 is 3, so that would mean x is 1/2. All right, now for the fun part. Let's do properties of logs. So we've got everything you need to know about logs in this box. Let's go through them. Ln of, and I'm stating them all for natural log, but they're all true for log of any base. So ln of xy is ln of x plus ln of y. Ln of x over y is ln x minus ln y. Ln of x to the r can come out front as a factor. That's r ln x. The inverse properties. If you take e to the ln x, they undo each other since they're inverse functions, and you get x back. And in this case, x has to be greater than 0 because you have to make sense of ln x. Ln of e to the x is also x. Ln undoes what e does, and that's for any x. And finally, the change of base we're going to need when we start taking derivatives. So I like to change all my logs of a different base to natural logs. So this is ln of x over ln of a. And I'll remind you of that later in the course. Okay, true, false. If it's false, rewrite it to make it true. The first one is false. It should be ln of x squared is 2 ln x. So in this case, we're squaring the whole logarithm. That's different than just squaring the x. Okay, second one is also false. Let's look at the left-hand side. E to the ln x minus ln y is e to the ln of x over y, which is simply x over y. Next one's true. Ln of 1/2 is, I'll just say y, ln of 1/2 is ln of 1 minus ln of 2, but ln of 1 is 0, so this is negative ln 2. The graph of y equals ln x passes through the point x is 1, y is 0. And finally, we have another false one. If we want to bring this 2 up as an exponent, we need to bring it up and apply it to the 3 and the t. So it should be 2 ln of 3t is ln of 3t squared, which is ln of 9t squared. All right, and let's use the properties to write this as a single log and simplify it. There's more than one correct way to do this. I'm going to start with the first expression and factor a 3x out. 3x times x minus 3. And then I'm subtracting 2 ln of 3x. Now I'll use the product property on this first one. This is ln of 3x plus ln of x minus 3 minus 2 ln of 3x. All right, if I have ln of 3x and I take away 2 of them, that leaves me with negative 1 of them. So that's ln of x minus 3 minus ln of 3x. And finally, we can write that as a single log. That's ln of x minus 3 over 3x. And that's fully simplified. Okay, let's do 2 more. Write this expression as a sum or difference of logarithms. Express powers as factors. That means bring exponents down. So if I start just using the division property, this is ln of x to the 9th root x minus 6 minus ln of x plus 1. And you need the parentheses around the x plus 1 because you're taking log of the whole thing. And I'll put parentheses around this too. Now I'll expand this first part as ln x to the 9th plus ln of root x minus 6, which is x minus 6 to the 1/2, minus ln of x plus 1. And finally, let's bring those exponents down as factors. 9 ln x plus 1/2 ln x minus 6, you need those parentheses, minus ln of x plus 1. All right, and now let's solve an equation. First thing I want to do is combine these two logarithms. So this is log base 2 of x plus 7 times x plus 8, and that equals 1. Now let's rewrite this statement in exponential form. So this is if and only if, that's what double arrow means. This means that 2 to the 1 is x plus 7 times x plus 8. Okay, 2 to the 1 is 2. X plus 7 times x plus 8 is x squared plus 15x plus 56. Now subtract 2 from both sides. 0 is x squared plus 15x plus 54. Factor, this is x plus 9 times x plus 6. So we get two answers. Supposedly, x equals -9 and x equals -6. But when you're solving logarithmic equations, you always want to go back to the original equation and make sure your answers are defined everywhere. So x equals -9 is not defined in this equation because you can't take the log of a negative number. If I put -9 in for x, I'd be taking log of a negative number. So there's only one answer. All right, and that is the end of this brief review.